working with subgroups. When working with situation, I don't know, come on, you always want to do this. So, okay, so what we're gonna do, we're gonna work with subgroups, and these strategies that are listed over here for us to follow, we're gonna see what those look like straight into our example, because they don't really make much sense by themselves, or do they? I don't know. So, our strategies, maybe let's just see what we're going to do and we'll apply them here. So we'll first determine how many ways there are to position a particular group. Then we'll determine number of ways to arrange the items within that group. And finally, you'll see how many different ways there are arranged items not in the group. And of course, we multiply all of those together because that's that and that and that. Okay, so let's just run through. I think there are four examples, or one example with 4 different ideas. So the first one is, there are no restrictions on who must sit where. So we've got 6 people here. Andrew, Brian, Charles, Doreen, Esther, and Frangipani. How many different arrangements are there if there are no restrictions? So, for this one, we got 6 seats. And if you want to write blocks, that's kind of how we've been getting into this. Or maybe you just put 6 lines. Advantage of lines is that they're a whole lot quicker to draw than these blocks. Blocks I like the idea of, because I can think, okay, well, Andrew could sit there, or Andrew could sit over there, Frangipani could be over there. So, but it does take a bit longer. So if we look at it here, we could say, well, for the first seat, anyone could sit there. So there's 6 different options over here. For the second one, there 5 people left to possibly sit there. 4, 3, 2, 1, and don't worry, that's not the final countdown. So, we could just multiply these together. And we did one of these examples previously. But there's a shorthand way of writing this now. And 6 times 5 times 4 times 3 times 2 times 1, we can write as 6 factorial. So with that exclamation mark. So it feels like you're like 6, but it's just 6 factorial. And on your beloved calculator, where's my calculator? Here somewhere. There we go. On the top right, sort of on this version of the calculator, there's that factorial button there, so you can just go 6, shift that, equals 720. I'll hold out quicker. Calculator, boom, I don't know, kind of comes and goes. 720. But quite a lot quicker than writing 6 times 5 times 4 times 3 times 2 times 1. Hey? Well, I mean, what a rhetorical question that was. Okay, but anyway, there's the first one. Now let's get into our subgroups and make it a bit more interesting. So in this next one, what we've got is Andrew and Brian, they got to sit together on this one. So they're really, I don't know why, but they need to sit together. So let's have a look. So we've got our 6 seats still where everyone wants to sit, but Andrew and Brian, as I said, they're sitting together in this one. So in kind of our group, what we're going to look at, our group of Andrew and Brian, they could sit together over there, right? So that's one option. They could sit together there. That's 2 options. Third option is they sit there. Fourth option is there. And 5th option is there. Clearly, they can't sit there and there because they're not sitting next to each other anymore, because the seats are in a row. Would be interesting if they were in a circle. So, 1, 2, 3, 4, 5 different ways that they could sit together. Then we look at the number of ways that within that they could sit. So you could have Andrew Brian, or you could have Brian Andrew. And you could have that for each of these, Andrew Brian or Brian Andrew. So in each of these 5 options, there are 2 ways that they could sit. Okay, then what we need to do as a final step is multiply that by how many different ways can all the other people sit. Charles, Doreen, Esther, and Frangipani. So, if Andrew and Brian sat over here, we could have, A, B, C, D, or we could have had B, A, C, D, etc., etc. So in other words, there could have been 4 ways to sit this one, 3, 2, and 1. And that 4, 3, or 2, 1 could have been in any of the other 4 ways of doing it. So for this third bit of our equation, our working out, we're saying how many ways can the others sit together? Well, they're 4 times 3 times 2 times 1. What's a shorter way of writing 4 times 3 times 2 times 1? 4 exclamation mark, right? 4 factorial. So there's our working, which means it's going to be a whole lot quicker to plug into the calculator. And let's do it. I've got my calculator here. And just to check that you are on track and multiplying this out, of course, the question is, what do you get? Okay, and I get 240. Now, if I was feeling like a real big fancy pants, and we don't really need this at this stage, I might recognize that 5 times 4 factorial, so this is just a quick aside because it's interesting enough, that 4 factorial, that part 4 factorial is 4 times 3 times 2 times 1. And so if we multiply that by 5 times, what we really just got is 5 factorial. So to work that out on the calculator is, I got 240, is you might have gone actually 5 factorial times 2, and we still get 240. To be honest, I would skip that. There's no, I don't want to put a cross. I'm just going to say rather skip that interesting aside though. Okay, onwards, upwards. 6 people sit in a sense of deja vu here. Okay, so we know these 6 people are sitting on a bench. And again, straight bench, kind of assuming not a circular bench. But that, I mean, why couldn't we have a circular bench? So in this case, all the girls have to sit together. Now, as always, we're just going to kind of assume that Doreen, Esther, and Frangipani are the girls in the group. So I'm going to put G's over there for them. And for the boys, I guess that's going to be too similar color. Let's go B, 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 right, for the boys. Now, we've still got our 6 seats. 1, 2, 3, 4, 5, 6. So for this one, we need to see how many different ways can the girls all sit together. So, you know, there's where they could all sit together. That's one option. 2 option, second option there. Third option, and the 4th option over there. So first of all, we look at how many different ways can we seat the group of girls. Then we look within that. So within the idea of we've got the group of girls, how many different ways can this happen? Well, we could have 3 ways to see who fits in the first one, Doreen, Esther, or Fran. And in the second one, we've only got 2 left because one of these people has been seated times 1. So when we look within our group, we're going to say, well, within the group, there are 3 factorial ways of doing that because it's 3 times 2 times 1. So this factorial is really coming in handy just to make our lives a bit quicker. And then we're going to see, finally, how many different ways are there to seat the remaining people. Well, they've got 3 seats left. We're not clear where those 3 seats are, but in those 3 seats, how many different ways are there? Well, we've got 3 times 2 times 1. In other words, we've got 3 factorial ways. So we're going to multiply that by 3 factorial. I'm just going to scroll up to see how this was written. First, determine how many ways there are to position the group. So that was the first thing we did. So the first thing we looked at was how many different ways were there for the girls to sit together. So we highlighted and went, there was one way, there was another way, there was another way, and there was another way. So there are 3 different ways of seating all 3 girls together. Then, part 2. Next, determine the number of ways to arrange the items within the group. So part 2 over here, we saw, okay, so for these 3 girls that are sitting next to each other, how many different ways could they sit together? Well, we could place any one of the 3 in the first seat. There are only 2 left to place in the second seat. And finally, there's 1 way to do that. So 3 times 2 times 1 is 3 factorial. Okay, and then for our last bit over here, the last the last way that we do this, part 3, is that one at least. Finally, determine how many ways there are to arrange the items not in the group. So in this case, we looked and said, Well, the items not in the group were Andrew, Brian, and Charles. So Andrew, Brian, and Charles were in 3 seats. Now, their 3 seats didn't have to be together. They could have been there, there, and there. But the point is, there were 3 seats they had to fill. How many different ways could we do that? 3 times 2 times 1, 3 factorial. So there's running through what we did. And from there into the beloved calculator. And we write 4 times 3 times 3 exclamation mark. What do you get? And before we head in, we're only doing one more example for working with subgroups, like getting a little bit of a sense here of how this works. Okay, 144 is what we get as our answer for that one. 144. And yeah, let's see how you're getting on, kind of picking up on some themes from the previous one. Okay, for our last bit, 6 people sit on a... We've done it. The girls have to sit together and the boys have to sit together. So here we are at our junior school dance, and we've got 6 seats, and the girls are all sitting together and the boys are sitting together. So let's just see, how many different ways are there of the group of girls to sit together and the group of boys to sit together? How many different ways could we seat those groups? Okay, well, the way I figure it is that the girls could be sitting over there together, and then the boys would be sitting there together. Or we could pretty much have it the other way around. We could have the boys sitting together there and the girls over there. And that's about all we can do, because if we had the girls sitting together over here, then the poor boys are not sitting together. So what we've got is 2 different options, right? Either it's going to be girls, boys, or boys and girls. So we got 2 options to seat the groups. Then we see how many different ways are there to seat the items within the groups. So we have to look at both the girls and the boys. So if the girls are over there, well, it's a 3 times 2 times 1 scenario. These seem to come out quite a bit. So what we've got is 3 factorial ways of seating the girls. How many ways are there of seating the boys? Well, similarly, you're going to have 3 factorial ways of seating the boys. There are no items that were not within our groups. So there's our calculation. And into the calculator it goes. 2 times 3 times 3 factorial, and I get 72 ways. So on that note, I think we head back.